Hello, welcome to the video demonstration of the eLab prototype board developed during our DARPA Young Faculty Award project. We will first describe the capabilities of our prototype. Then we will describe the calibration and the gate analysis experiments. Finally, we will present the wireless network topologies used in this work. The test prototype board consists of a TI CC26X2 microcontroller with Bluetooth Low Energy connectivity. It also has an onboard MEMS 9-axis accelerometer sensor and has an option to add a band angle sensor and a memory card. We manufactured both physically flexible and rigid versions for debugging. We can harvest energy from ambient light and human motion, as demonstrated in our second video. The average power consumption of the whole device, including sensing, processing, and communication, is around 26 milliwatts, which can be delivered by our energy harvesting techniques. The sensor board can act both as a server and a client. The server node advertises its availability until it is connected to a client device. The connection from the client device initiated with a button press, so for each button press, one device will be connected. After establishing the connection, 65 bytes of sensor data is transferred every 7.5 milliseconds. The accelerometer and gyroscope readings are used to compute a variety of features, such as joint angles. However, the raw sensor readings are not reliable. The accelerometer data alone cannot be used to calculate SD angles, since it is noisy. Similarly, the gyrometer data alone cannot be used as the values get drifted after a short time. Therefore, we fuse their reading using a complementary filter. For illustration, we will show the angle of the z-axis with the horizontal plane, a demo. In this experiment, all the boards are glued to the back of a clipboard, and all the boards are connected to a central client device, and the sensor data is logged from the client device. The clipboard is opened and closed, and the boards are moved from 0 to 90 degrees. The sensor in the sensor boards are sampling at a rate of 200 Hz, and the data is transferred over BLE at a rate of 9 KB. Each packet from the sensor board contains 6 bytes of accelerometers and 6 bytes of gyro data. In this experiment, the angle along the z-axis of the board changes from 0 to 90 degrees. The miniature prototype boards were also used for conducting gate experiments. The boards are attached to a knee sleeve worn on by the user. The sensors measure the hip and knee angle, with which the gate values is calculated. Subjects were made to walk over the gate right matrices, which measures the ground truth value of walk. Finally, we describe the wireless network topologies used for connecting multiple sensor boards. This slide shows a star topology with a gateway and 7 client devices. In this example, all 7 client devices transferred 65 bytes of data to the gateway at 7.5 milliseconds. The gateway is connected to a laptop, which receives and displays the aggregated data. This slide shows a more scalable topology with 2 gateways and 5 clients. It can be extended to 14 clients by connecting 7 clients to each gateway, as shown in the previous slide. Thank you for watching our demo. The energy harvesting capabilities are described in a separate video. For questions, please visit eLab webpage at Arizona State University.